Up, bench, and we are live. Let me wait until the audio is there so I can check that the audio works. Up. Okay, audio works. This is quite an impromptu stream simply because I was concluding the project. So last time we looked at this battery. This is an e-scooter battery someone found and gave me. And the issue was that the output was not enabled. The power was not enabled. Oh, what happened to this one? Ah, okay, now I know. Ah, is this working? Oh, do I have to? Okay, this is not working. This, let's restart this. And yeah, okay. Now we have almost all USB working. The camera should be a lot more stable. Okay, it is not more stable because of other. Why wouldn't it be more stable? Ah, I wanted to do a quick stream and not debug anything. Ah, and now the camera doesn't work anymore. And does the journal say why? No, it doesn't. Let me just restart. And we should be back. And the audio, let's wait until the audio is there. Yeah, we should be back. So I fixed the bandwidth issue with USB. So I changed my USB configuration and it was stable, but I didn't test it at the same time as I used my multimeters, which you don't see here. So now we have only one camera. I don't know why. There's enough bandwidth for the second camera, but as soon as I start the multimeters, I cannot use the overview camera. But we'll just use this camera, and at least we will have the multimeter views, which is more important. So, coming back, impromptu stream. Last time we had this battery, we had and we wanted to reactivate it so we can use it for anything we want. The issue was that I found code on a forum which sends the data. This is over CAN. Last time we were able to send the messages over CAN, we were able to see them, but it still didn't work. I still didn't have any output. And while tidying up, I probably just created a small short or something else, I don't know, or a small contact, and I wanted to investigate what was happening because I was getting output, and I am getting output. You see on the multimeter, the value here you see on the screen, 47 volts. This is directly the output from the battery, which is connected there. These are these two clips. These are the 47 volts. And we actually have some power, and we can draw power. Can I show you the power drawn? Let me use the second multimeter. Let's put into amps. Up. Ah, for now it doesn't work. Okay, we have an output, but it's not complete because you see this red light. Up. Let me get the battery a bit. This red light is blinking, and it means there is an error, but I didn't have this pattern before. This is a new pattern, so I think the CAN messages work. So the CAN messages, I've modified a tiny bit. I also used the hex, and we were able to send the messages. We were able to record the messages, and this is the original code. I was able to listen to CAN messages here, and we can still do it. Let me show this to you that this actually also works, sending the CAN messages. So for that, I will let me finish this, and I will split the screen so you can see the messages. Up, this we don't need. It's this one, 4. Up, screen. So on the left you see this. Okay, you don't. Now you can see on the other one, but this is the other device. This device which is listening to the port. And if I shouldn't be shouldn't need to flash it, but if I flash it, and yeah, you don't see everything out of screen. Everything is out of screen. Why don't you want to flash? The port doesn't exist. Why shouldn't it exist? Rejected configuration. Because now it exists. Okay. Because I was playing with USB. So it is flashing, it is connected, and now it's waiting for CAN messages to be sent. And if I enable power to the Arduino, this way we should see the CAN messages which are being sent. These are the original code, and we see that the CAN messages are sent, and we are able to transmit it, to receive them, to monitor it. Now when I switch off, you see there's no activity anymore. Well, it's on the other side. This is the bench. Using this hub, this connection goes to this ESP32, which is in monitor mode, and this connection, which was powering, is sending the CAN messages. Using this CAN module, and the CAN module is connected to the CAN interface. Well, not completely though, because it is missing this small piece here. But it was still working and acting correctly. So the issue is, do you see this connector? Let me try to zoom on it, but I cannot move the setup too much because this is very flimsy. But this connector here has 3 pins. This is the CAN connector. We have orange, we have green, and we have black. And we know it is CAN because we are seeing that the CAN messages are getting ACT. And then we have the power connector here, which has 3 wires actually. It has 2 black, so one for the output, thick black, one thin black, this is probably for charging, and one red, which is really the output, and it is as thick as the thick black one. So we have a separate connector just for CAN. This is a dual-LED connector with 5 pins, and they are only using 3 pins. So I thought, yeah, we have a black wire, one is ground, the black wire is ground, and then the 2 other wires are data wires. And although you don't really require ground for CAN because it's a differential signal. Well, you do still need it. I thought, yeah, this is ground. Turns out that this black wire is not ground. Yeah, who knew that? A black wire with digital pins on the sides, it's not ground? No, it's not. This is the black wire which is going there. And if I connect it to ground, I have to go back so you see the LED. Here you see the LED. I disconnected it to ground. It is now floating. When it is floating, the LED is red. It is red for 10 minutes. Afterwards, it clears. When I put it to ground, oh, and actually you even see on the multimeter, if I leave it floating, on the multimeter, you see the voltage is low. It is at 0 volts, so it's disabling the output. So there was nothing with it. Now, if I put it to high voltage, you see it's at 47 volts, but what you don't see on the multimeter is that it is moving. This is what I can show you on the oscilloscope. Oscilloscope capture. Let's enable the oscilloscope. Oscilloscope, and this is what you see. Every time it triggers, you see this dip, and what you can see is that the blue line or turquoise line, this is what's connected to the battery output, and it is at 48 volts, but it is repeating this slow pulse as it would be resetting. It shuts off the power. It goes low because there is a teeny tiny charge, but this is discharge of a capacitor, the curve which you see, and then it goes back high to try again the output. So what is BMS is doing, it is checking that the output is correct, and it turns out that this is not a ground wire, this is a sense wire. And let me shut the oscilloscope off. Now, if I connect this sense wire to the plus of the battery with this thing up, then the red LED clears and we have 47 volts directly the output from the battery. And now I can show you that it is actually the battery, and the battery can provide some power. And so this is ground. Let's connect this lead to this resistor. This is a 1 kilo ohm resistor capable of 5 watts, so lots of energy. And we see that we have 0.67. Do we see it? Yeah, we have 0.6 amps flowing through this 1 kilo ohm resistor. And this is directly from the battery. We can have a lot more energy if we're using this 10 ohm resistor. Since we have something around 47 volts, we should have around 5 amperes. If I connect this, and then we have plenty of wires which are going everywhere, so the resistance is a bit higher, you will probably have less. And the output now is not right because I'm not measuring the right thing. I didn't plug it correctly. I don't know what it measured though. Now, here we have 4 amperes. This is the output of the of the battery, and this is getting warm because 50 volts and 5 amperes going through it, and now nothing anymore. Why wouldn't there be anything anymore? Did the fuse break? There's no voltage. There's no output voltage. If I disconnect it, the output is off. The battery is off. Is it? Oh, did I draw too much current at some point? This is really warm. And now you see we have 3 volts only. But the output should still be on, because when the output is on, you cannot use this touch button and see the power output. So what is happening? Is there a loose wire somewhere? No, it's completely off. If I look at the oscilloscope, the voltage is really off. And it says that there is an error. Okay, this is because I disconnected this line. Now, if I reconnect this line, it clears the error and the output is still on. I don't know what happened. Maybe there was too much current. That's not possible because this is able to do a lot of current. So we're completely able to use the battery now. And the real issue is that this black wire, which is on the CAN port, is not CAN. It's actually the sense wire for the 48 volts. And when you connect it to the 48 volts, so when it is plugged in the charger or in the e-scooter, it's interconnected, and this is how it verifies that there is actually a power output. And the ground wire is just a ground wire which you have to use for CAN, which you have to use from the power plug. And what also works is charging. So yeah, you can see it here. I have this module here, which is a voltage booster, because to charge it you need at least, in theory it goes up to 54.6 volts. So you need something more to pump power. You need something more than 50 volts to pump power into it. And I don't have a power supply which does more than 50 volts. My bench power supplies do less. So I'm using a voltage booster, this one, which boosts it to 58 volts. And this is connected to the other wire, which is used to charge. And if I now enable the output, which you see on the bottom, 27 volts are enabled. For a tiny bit of time, it draws the 40 milliamps, and after some time, it should draw a lot more energy. Yeah, and now it draws 5 amps, and we're in constant current mode because my power supply is limited to 5 amps, and energy is going into here, and we see it because this display is on, and it's hard for you to see, but there's a blinking percentage sign, meaning we are feeding power in. And we can also verify that the CAN is right, because on the screen, we see this output now. So the battery is sending over CAN. Currently, it's charge status and probably something else, but there is this value here is incrementing with the one with this ID. You see it's BA87 and then B88B and so on. So this is, I don't know what kind of value it is, if it's voltage, millivolts or percentage, or I don't know. But this value is increasing because it is charging. My power supply is struggling though. This is not meant for charging. This voltage booster which I'm using is not meant for charging this battery, so it is making some squealing noise and saying, no, help me. So charging works, the output works, and now what I don't know is which of the codes which are being transmitted by the Arduino is the right one to enable the bus. So we see that the battery is still on, although we are not periodically sending data. Generally on CAN, what you have is very periodic messages, like a keep alive, and when there's nothing, it means something is off, turned off, or something is not normal, and then it shuts down. Here on the battery, you just have to send one command, probably, or a couple of commands, and it turns on all the time. And this has been on since 18 hours, the battery, and it didn't shut off. And I don't know how to shut it off. So we always have the power output now. I think it was disabled by default because I never had, when I had this cable floating, I didn't have this error message. So it means that the CAN messages were used to send to enable the battery. So the code is working, which is on the Arduino. And what I did is then I created, because I only have one of these Arduino, and I generally use it for projects which people implement on the Arduino. Like here, somebody wrote code for that. I used the code works, and I re-implemented using this Arduino, this ESP32C3. Here there is a CAN transceiver, and now I just have to plug to the CAN, press one time on the button, on this button, and it sends the messages, and that's it. With that, I can re-enable the battery, and I could re-enable any of these batteries. What's important is that once you enable it, is that this needs to be connected to the voltage, to the power, to the how is it called? The voltage output of the battery. And on this connector, this was at the bottom, this is the original connector which I cut off to figure out which connection is what. Now pin 1 is the battery output, pin 4 is ground, and pin 7 is actually the monitor. So if you short pin 1 to pin 7, this is on this connector, this is what the connector is doing. This is how you connect the sense wire to the voltage output, and then you get output. This connector, by the way, is reversible. This, you see, for example, for this trace goes to here. So, and you see actually the output. This is the black wire. Probably you don't see it, believe me, this is the black wire, which is also going here. So whatever is on pin 1 is also on pin 14. So what you could do is short 1 and 8, these two. So this is the sense, this is the battery output, this is the ground for the battery. There is, and the other pins we can check actually. This is the pin 3 is ground for charging. Then we have this one. This is pin 2 is CAN high, and the last one, this one, pin 6 is CAN low. Now you have the decoding, so you just need one of the things. 1 battery output plus, 2 is CAN high, 3 is charging ground, 4 is battery output ground, 5 is not used. Yeah, it's not used. 6 is CAN low. Yeah, 6 is CAN low. And 7 is voltage sense. and then reverse it to get the same on the other side. Now we have the connections, we have the code, which is, well, you can get it from the forum. I showed you how it is. I may publish my code. This one can send and receive data, and you just have to press once on the button. Else here, you just have to create the same setup, plug it, and that's it. And with that, we have a working battery, which is quite nice. And I would love to have the power out indicator, but I really don't need to. And what's funny with that is this is 48 volts. And I said I didn't have anything which handles 48 volts and can step it down, but you don't need to, because, well, or I don't have also an inverter which handles 48 volts. The inverter I have is 12 volts or 24 volts, which are usually car batteries inverters, but not 48 volts to create AC. And the idea we could use it for is using this battery as power station with an inverter. But what's funny is that, let's be prudent because there's plenty of energy. I already vaporized some metal when shorting these two leads. Now this lead, let's connect it here. Let's have the red wire here. So now we have the power enable output. You see we have 47 volts again. And this is just a power supply, switch mode power supply. If I connect it, and it's 12 volts. If I connect it directly to the battery, so remember these are 48 volts DC, this should be at least what's specified is 100 volts to 240 volts AC. And now if I measure the voltage, let me switch the leads. Let me go to volts on the multimeter. Let me get the multimeter. Ground and plus. We see there is 12 volt on the output. So we can use this battery directly on power supplies, which are switch mode power supplies. I don't know if it works on all of them. I tried most of them and it works perfectly fine. Probably not very efficient, still efficient enough. And it's just, the chip just doesn't have to care about the 100 volts and still be able to output 12 volts. And it worked with plenty of other things. So we could use this battery, have directly mains, plug things into it, and then it works. No inverter needed. Probably not very efficient. I don't know. It would be fun to try how efficient it is. Who cares? And then now I need a charger for this also. These are 13 batteries, 13 LiPos in series, and I don't have a charger for that for now. Because I didn't know if the battery would be working or not. Now the battery is working, and yeah, it's good. And maybe there will be plenty of other batteries with that. I'm not sure if I will do a recap of the thing. I'll probably publish the code with the documentation, and yeah, somewhere on my Git. I'll publish on my Git. There will be a documentation page. Look for the tier unlocker. And with that, the project is done, and we have a battery working. And I'm using these connectors. So I've soldered my own connectors. I just have to solder this sense wire to this connector, and we are done. We have a battery, and this is what I wanted to do on this stream. So now you can do your own. You have all the documentation. You just have to watch plenty of hours of stream, or you have to wait until I publish my documentation and code. But that's it. And with that, the project is done. Enjoy.